In this example, we have a ratchet and pawl mechanism with the motor driving this, and we can drive it at a constant RPM, or we could put an input grapher to tell it how we want to drive this. As this drives, it's going to cause this pin to oscillate back and forth, and then this finger is going to catch on the ratchet and cause it to index forward, and so it will go forward a certain amount, and then it will return a certain amount, but not the entire distance, so that eventually this blue pin and this red pin will go all the way around in a circle. So let's look at that operate. So this motor rotates continuously in a circle, oscillates back and forth. Here we see that blue pin is indexing forward, so it indexes forward another step. This will index forward and then go back a certain amount. This is the path. So maybe even not even consider any of this part of the mechanism. Maybe you just need some kind of push rod that will follow some path, say to close a box lid and push against that box lid to seal it or something. And then the spring keeps the pawl against this. We'll look at this spring force. And so we see how that spring force holds this part against this part. So let's look at how to set all this up. I'll start a new metric part file. I'll go ahead and save this as backplate. And I'll start a new sketch on the XY plane. I will draw a rectangle someplace in space about like that. I'll dimension the distance from the bottom horizontal line to the origin as a height of 70. And then I'm going to dimension the overall height of this rectangle as 200. And I will dimension the horizontal distance from the vertical line to the origin as 70 as well. And I will dimension the width of this rectangle as 325. Let's arrange those dimensions. Alright, then I'm going to draw a circle at the origin, and I'll do this circle as 15.1. I'll draw a second circle at the origin, and I'll do this one as 25. I will draw a circle in this area as 5.1, and then I'll dimension the location of that circle to the origin as 52 and vertically to the origin as 50. I'll then draw a second circle here, and I'm going to make this one equal so that I only have to change one dimension. I'll make those two circles equal in diameter, and I will dimension the distance horizontally to the origin as 35. The dimension vertically to the origin as 52. I will draw a circle over in this area below the origin, make this circle equal to the original circle. I will dimension the vertical distance as 13, dimension the horizontal distance as 125, and I'll draw a circle over here, make that equal to the original circle. I'll dimension the horizontal distance from here over to here as 225, and I want this one located straight over, so I'll do horizontal constraint between this point and this point. Everything turns dark, it's all fully constrained. I'll draw another circle at the center of each one of these small circles. I'll dimension one of these circles as 7.5. And then holding the control key down, I will select all of these circles and make those circles all equal. Everything is all fully constrained. I might rearrange the dimensions a little bit. So there are my dimensions. I'm then going to do some extrusions. I'm going to turn off the visibility of the sketch dimensions to clear up the screen a little bit. Then I'll do an extrude, and I'm going to extrude this area. I want to send that going towards the back, a distance of 20 millimeters. And I want to also get this area right in here, this area, this area, this area, and this area. So I left the smaller circles as holes. I'll say OK to that, save my file. I will make that sketch visible again, and I'm going to do extrude again. This time I'll select this area outside of the outside circles, and I'm going to flip the direction, have it on cut, and I'm going to cut back a distance of 15 millimeters. Then I'm going to do extrude again. This time I'll select this area and I'll select this area. I'll flip that direction, and I'm going to cut back a distance of 10 millimeters. I'll hide the visibility of the sketch, and I'm going to apply a color to this, or an appearance. You can apply whatever appearance you would like, maybe an aluminum or a chrome appearance or some color, and that finishes this part, so we can move on to the next part. I'll start a new metric part file, and then I'll save that as Ratchet. I'll start a new sketch on the XY plane. I'm going to draw a circle, and I'll make this circle a diameter of 100. I'll draw a second circle. I'll make this a diameter of 80. Draw a third circle. I'll make this one 15. For the two outside circles, I'll change those to construction. I'll draw a vertical line up from the origin to the 12 o'clock position, and I see that it didn't turn dark, so I didn't get it vertical, so I'll add a vertical constraint to that line. I will draw a line down to about here, and then from this point back to the origin. I'm going to dimension the angle between this line and this line as 22.5, and everything turns dark. It's all fully constrained. I will then extrude this area in here a distance of 10 millimeters, and then I'm going to do a circular pattern. I'll select pattern solid, and so I have a choice of pattern feature or solid. Whenever possible, you want to pattern the solid body rather than the feature. And I'll get the rotation axis around the z-axis, and I'll tell it that I want 16 copies. And I'll say OK to that. Make sure that it's set to join those together. The other option would be to create new solid bodies. I want these all to be joined together. I'll create a new sketch on the XY plane, and I'll draw a circle at the origin, a diameter of 66. And then I'm going to draw a vertical line from the 12 o'clock position down to the 6 o'clock position. We see that it doesn't automatically constrain that. I'll do a coincident constraint between this line and the origin. And it didn't constrain, so I need to put a vertical on there as well. So I'll do vertical. Now we see that it all turned dark. It's all fully constrained. I'll change all that to construction. I'm going to draw a circle up here, diameter 3. I'll draw a second circle down here, make those two circles equal, and then I will do extrude, and I'll select these two circles, extrude those with join a distance of 15, and I want them coming out in this direction. I'll save my file. I'll apply some appearances to my model, so I'm going to make that driftwood, and then I'll select this face, right click and go to properties, and I'm going to make it blue, adjust that appearance onto this face. I'll change the properties of this face to red, and maybe drop that same appearance onto this face. I'll save this file. I'll start a new metric part file, and I'll save this one as Pawl, P-A-W-L, and then I'll start a new sketch on the XY plane. I will draw a circle at the origin, a diameter of 5. I'll draw a second circle at the origin, a diameter of 10. I'll then draw a line over horizontally from the origin, a distance of 15. And I will draw a second line from the 6 o'clock position over here, tangent. Now, if you hold the mouse button down and drag that mouse, notice it's going to put a tangent constraint on there. I also want the horizontal constraint. I I will then do the same thing at the top. So I'll click someplace on this circle, hold the mouse button down. Notice it'll put that tangent on here, and I want also horizontal, and then I'll come down to this point. Let's put a dimension in there of 45 degrees, and I want to do a length of this as 33, and I want to put a circle this end, diameter 3. Change this line to construction, and we can either leave this circle in as it is, or we could trim it. I'm going to go ahead and trim it. Then we'll extrude that a distance of 10 millimeters. Give it some color. When you are using the adjust, you can color a face, or if you bring the eyedropper over to an edge, you'll see it picks the entire part, or you could come over here and select the part over here, and then you could pick up a color from the paint bucket. I'll save that. I'll start a new metric part file, and I'm going to name this long link. I'll start a new sketch on the XY plane. I will do a slot. I'm going to do a center to center slot, and I will select the origin. I'll come over about like that. I'll dimension the radius of this arc as 5, and I'll dimension the center to center distance as 50. I'll draw a new circle at the center of this arc, and I'll do that as a diameter of 5, and I'll draw a circle over here, make this circle equal to this circle, and I will extrude this a distance of 10 millimeters and give it some color. Then I'm going to do a file, save as, and I'm going to call short link. I'll edit sketch number 1 for the short link. I'll change the 50 to 25. Finish sketch and save it again. I'll start a new metric assembly file. I'll save the assembly file. I'm going to call it Ratchet and Pawl. And I'll place the back plate. I will right click, place it grounded at the origin. I'll then do place, and I'm going to select the ratchet. I'll place it someplace on the screen, and I'll do an insert constraint of this ratchet onto this circle, and then I will do place, and I'll get the long link, and I'll constrain and do insert one of the holes on the long link to this circle, and then I'll do place, and I will get a short link, and we'll constrain it, insert this circle to this circle, and I'll do place. I'll get the pawl, and I'm going to constrain it with the insert this circle onto this circle. I accidentally placed these twice, so I'll delete the extra one. And now we need to model our arm that indexes the ratchet. So I'll start a new metric part file. I'll save this as arm. I'll start a new sketch on the XY plane. I will do a center to center slot. I'm going to put this someplace in space. Make sure that line's horizontal, about like that. And then I'm going to dimension the distance from here to here as 20. And then I'm going to dimension this distance as 225. I'll do coincident this line to the origin, but not at the midpoint. I will then dimension from the origin over to this end of this profile as 100. I'm going to draw a vertical line up from here up to the center of this arc. I'm going to draw a horizontal line over to about here, and then I'm going to click and drag an arc off of that line. Now if you have trouble doing that with the click and drag method, then just do it as a separate arc. So I'll let go there, and then I'm going to click and drag and draw a second arc down to this line. I want to make sure this one is tangent to that line, so I'll do tangent, this arc tangent to that line, and these two arcs should already be tangent, and this line and the arc should already be tangent. I'm going to dimension the distance from the end of this arc over to the origin as 10, and I'm going to dimension the radius of this arc as 50, and I'll make these two arcs equal radius. Everything turns dark, it's all fully constrained. I will draw a circle at the origin at a diameter of 5. I'll draw a second circle at this end, make this circle equal to this circle, and then I'm going to do extrude. I'll extrude this area in here a distance of 10, give that some color. I'm going to make mine yellow. You can make yours whatever color you like. I'll go back to my assembly, and I'm going to do place. and I will get the arm and place it into my assembly. Now let's go into dynamic simulation. So I'll go to environments and I'll go to dynamic simulation, and we see that we have a revolution joint at this length, we have a revolution joint here, and we have a revolution joint there. I don't have a revolution joint at the ratchet, so remember how to get that. Now yours might have come out differently. I'll right click on this ratchet and I'll tell it retain degree of freedom. That adds a revolution joint for the ratchet, and then I'm going to do C for constraint, and I'm going to do insert, and I'm going to insert this circle onto this circle, and I'm expecting when I say OK that it should add another revolution joint. And so I see the arm is in the mobile groups, and it did put a revolution joint there. Let's drag this up some, and then I'll attempt to put an insert constraint between this circle and the circle on the back side of this arm. And let's watch to see what happens when we say OK to that. So I'll say OK, and it put a point line there automatically rather than a revolution joint. Now in earlier versions of Inventor, we might have had to add that point line ourselves, otherwise it would give us an over constrained condition. I'm going to drag this part up where it's below the ratchet but not interfering, and then insert joint. I'll do a 2D contact between this face. Now we're trying to find a loop. It could be this circle, it could be this circle, but actually we want the outside. So I'll select the face, and then it has to select an edge. I'll select any of these lines on the edge, and I'll second curve. I'll select this face. Again, it could select this circle, this one. We want the outside edge, so I'll select one of these lines on the outside edge. I'll say apply to that, and then I also want to do a 2D contact between this part, and I select it. It could be this circle, we want the outside edge. I'll select that edge, and then for the second component I'll select the ratchet, and I need to select the edge. We'll say OK to that. Now if I try to drag this, we'll see that as it comes down here, it comes in contact, and then as I drag this over, when it comes in contact, it stops. Now we saw this part fall over a minute ago. It just fell over, and so I need to put a spring holding it from there to there. Now when we do this, we're doing a spring force. So I'll do an insert joint. I'll tell it to do a spring dampener jack. It asks us to select a point. If I select a circle, it will find the center point of that circle, and then I'll select a second point and I'll say OK to that, and it puts a spring force in between those circles. Now actually notice that this force is at an angle, so I may want to set this up in such a way that that force is not at an angle. So I undid the creation of the spring force, and I know the distance from here to here is 10 millimeters, so I'm going to bring this up another 5 millimeters. So I'll shift right click and put my selection filter on part priority, then open up this part, and I'll turn on the visibility of sketch number 1, and I'll do extrude, and I'll extrude that additional 5 millimeters, hide my sketch, save my file. I'll go back to my assembly, and so I brought that up so that it's halfway. I'm going to open up this part, and I'm going to extrude it mid-plane. So I'll edit that feature and I'll put it mid-plane. I will put an axis in that hole, and then I'm going to do point, and I'll select this axis, and I'll select the XY plane. That puts a point in the middle of that hole. And when I did this, it flipped the direction of my insert, so I'll need to find that insert constraint for the pawl, and I'm going to edit that, and I'll flip that to the opposite direction so that it's oriented the way it was originally. And then we can see the point that we have in the middle of this hole for the spring. I'll go back to dynamic simulation, and I will then put a spring force back in here again. So I'll do constraint, and I'll do spring dampener jack. I'll select this point at the middle of that hole. I'll select this circle. It'll find the middle of that circle. I'll say OK to that, and it puts the glyph for the spring force in here. So we can do this contact one of two different ways. We could either do as 3D contact, or since these stay in the same plane, we could do it as 2D planar contact the way I did. Experiment with it both ways and see which solution works better. You may need to increase the number of calculations and experiment with the amount of spring force, and also experiment with the restitution and the friction value. You'll have to put an imposed motion on the motor to drive this. So I'll leave the rest of this for you to experiment using what we have learned so far.